Hi, I am Sina Keshvadi, and I want to present the paper MoVIE, a measurement tool for mobile video streaming on smartphones. My co-author is Professor Carey Williamson, and we are from the Department of the Computer Science at the University of Calgary. I'm recording this video for the conference ICP 2020. Over the last decade, a smartphone has become an important part of our lives. Cisco reported that 48% of the global internet traffic in 2019 was consumed by handheld devices such as smartphones and tablets. The emerging mobile web, supported by Wi-Fi and 4G, 5G cellular network, enable us to access the internet from anywhere at any time. The Cisco predicted that a smartphone alone will consume 50% of the global traffic at 2022. Among all internet traffic consumption, video streaming has the biggest share. Another prediction by Cisco reported that the internet video will be more than 80% of the internet traffic in 2020. Everything from entertainment, sport, business, educational institution, government, live streaming are increasingly using the video streaming services. The increase in the internet usage by a smartphone and video streaming services encouraged us to design and implement a mobile traffic measurement framework called MoVIE for analyzing video streaming on a smartphone from multiple observational viewpoints. The characterization of the video streaming on mobile devices can provide a good understanding of the video streaming behavior for us and enable us to analyze the data and optimize our services. MoVIE provides the player view, follow level view, and packet level view of the video streaming. Before jumping into the MoVIE structure, let's talk about the main feature of the MoVIE. The first one is visibility. Since MoVIE captures all incoming and outgoing internet traffic from different viewpoints, it provides a visibility of the video streaming. The quality of experiment measurement is the second one. Users usually expect a quality of experience that is not always well reflected by traditional network layer quality of service metrics. MoVIE reports the quality of experience provided by video streaming. The third one is traffic mapping. We propose a new mechanism to identify relationship between all generated packets, follow connections, and video player activities, the three observational viewpoints that we have. In addition, MoVIE provides the ability to compare up to 2 video streaming sessions. MoVIE is open source, and we try to design MoVIE in a way that be easy to use and customize. Here we can see the MoVIE structure. MoVIE consists of the 7 components. But before talking about the component, let's check the environment that we use the MoVIE to capture the video streaming sessions. MoVIE is running on the PC. That the PC can be Linux or Mac OS or Windows. We just need to have the Python installed on it. And we should install the man-in-the-middle proxy and T-Shark, 2 tools for capturing the data. Man-in-the-middle proxy is a man-in-the-middle attack tool. And it sits between the mobile devices and internet to listen to the network. The mobile smartphone device and the PC should be connected to the same Wi-Fi. The man-in-the-middle proxy CA certificate should be installed on the phone to allow the PC to listen to the smartphone. We designed a simple application, video logger, that capture and record all information of the video player and send them to the MoVIE. This is the 7 component of the MoVIE, and we will review them in brief in the next slides. The first one is the traffic interceptor. MoVIE all internet traffic generated by mobile devices during video streaming. To do this, we use a man-in-the-middle attack tool. So the information that the man-in-the-middle attack give to us is all response and requests, HTTP, HTTPS, response and requests. So we have as example here, for example, the method is get, the status and all information. The information is more than this, but because of the space, we just put a few lines of it here. Another one is the packet tracer that capture full packet traces of the internet traffic generated by a smartphone. We use the T-Shark, a terminal version of the Wireshark, to capture all traffic, and it sends the data as a JSON file to the MoVIE. This is an example of the information we need. The third one is the player view that MoVIE use the video player activity and events to measure the visual video quality metrics. We develop an Android app that collects and parses the video properties of the video player activities and send them to the MoVIE. This is one example of them. Is timeline based, and from the first fetching the URLs until the end of the video streaming session. The privacy view, this component investigates the capturing flows to detect potential data leaks. It receives flow from the traffic interceptor component and use EasyList to detect advertisement and tracking flows. EasyList has a list of all international tracking and advertising URLs, and usually it is used in ad blockers. The mapper, it maps the captured packets to the flows and then map the video activities to flows. So to do that, it first classify the flows and group them based on the established sessions, and then it classified the packets and map the packets to the flows. T-Shark, by default, it's classified the packet in the sessions. And finally, we map the video activities to flows. In the paper, we explain with the detail how this process is doing by MoVIE. The main component is the central part of the MoVIE that manage and coordinate all other components. It receives a follow list from the traffic interceptor, a packet list from the packet tracer, and video streaming activity from the player viewpoint. The mapper component assigns the connection based on all captured information. Then the main component analyzes the data, calculate the video streaming QoE parameters, statistics of the packets, and all other information. And finally, it invokes the graphical user interface to provide a visual representation of the results. The GUI, the graphic user interface, provides a multi-level visual representation in the form of the tabs and tables and graphs. The output of MoVIE is generated in the HTML5 format that has several advantages. It's portable, easy to use. You can easily export the reports, ready to publish, and easy to customize. So to show the MoVIE ability, we show you a case study of 360-degree video streaming from YouTube and Facebook. The experimental setup, we use the Nexus 6 phone that is running the Android 7, and the Chrome 72 is as a web browser on it. The PC is Linux-based PC, and it is the man in the proxy, and T-Shark is installed on the PC. The video logger is installed on the phone. We stream the Lion Cubs, a movie, 360-degree movie by National Geographic Channel that they provide them in the both platform, YouTube and Facebook. It's the same movie. So here is the packet level report provided by MoVIE. Because of the space, we just put a few parts of the report here. So MoVIE reports is divided into 4 parts. The first part is about the packet level, and you can see the information here, or the graph they're showing the receiving and sending the packets and the bytes. So for example, here we can see that the streaming in this device use a in-memory buffering method. It starts by preloading a certain amount of the video and audio in advance and play them, and then again download another chunk of the data and play that data. The flow level view provide a flow level study of the generated HTTP and HTTPS requests and responses. Here, for example, this shows the distribution of the flow type and size. And for example, here it shows a time series graph of the flow generated per second during the streaming. For example, here at the first, because it starts fetching the HTML and CSS email in the page, so it's create many flows. But after that, because it's just using flows to download the videos or maybe tracking the user. Here we can classify the flows to based on the get or post and other, or see the advertisement, the potential advertisement and tracking connections. Here is, if you click on any of them, you can see them in more detail. The player level view give a detailed information about the streaming events, and here is about the video streaming, the video codec, audio codec, and here is about the quality of experience metrics, the play start time, the audio rebuffering, the number of the video rebuffering, and the quality switch. So by using the YouTube, we didn't experience the rebuffering and quality switch. Here it's the last part. The tool provide a comparison of the 2 video streaming sessions. So here we can see that the same video by same provider, but in the YouTube has the different video codec and audio codec. In the Facebook has different video codec and audio codec. Even the resolution and the size of the video and also the pure metric, we can see that it was more quality switch and rebuffering in the Facebook. This is the 360-degree video streaming. So let's see a demo of the tool here. And here is the website of the MoVIE, and you can see the source code here. So the case study I show you, it was YouTube and Facebook. Let's see another case study, the TSN and free live streaming, the 1 monthly paid streaming and 1 free live streaming, just to show the movie. So it's a tabular view report, and it shows the all information and graphs here. This is the packet level, this is the follow level, and it shows all of information in the graph, and it's easy to provide the report. And this is the video streaming, and the video streaming activity timeline. It provides according to time, the fetching the URLs, the encoding, and the time of everything happened in the video player. You can see here them and what's happening in the video player during the video streaming. And this provides a comparison of the 2 video streaming sessions. For the future work, we want to work on the MoVIE. Currently, MoVIE just support the Android devices. We want to work on the MoVIE to support iOS devices. We just covered 4 QoE metrics, for general QoE metric, but it's better to provide some sophisticated quality of experiment metric. So MoVIE currently compare up to 2 video streaming sessions. We are interested to improve that to cover more than two video streaming sessions. And currently it's just local, it used the system local processing, but we are interested to provide it as a cloud-based tool. Thank you for listening, and I hope you enjoy the movie.